Hey there. So in this video, we are going to be discussing a little bit more about TensorFlow, specifically the basics. You might be asking yourself, what the heck is a tensor? It's in the name. It's not something that's really discussed all that often. And I know up until very recently, that was something that I had absolutely no idea about. But we will be discussing that today. So essentially, a tensor, as defined by the TensorFlow website, is a multidimensional array given whatever type. For example, this would be a tensor right here, or this. And essentially, it will initialize a tensor using the given array and type with a rank based on the array. And the rank is the number of dimensions of the array that are stored inside. So for example, with this guy right here, this would be considered a scalar because it is a rank 0. There are no arrays inside. And for those who wiped linear algebra from their brain the moment humanly possible, such as myself, a scalar is essentially a magnitude or a value without direction. So if you were to imagine a 3D graph, a scalar would be a point somewhere inside. So let's say we take our lovely little MS Paint graph right here. We could call this dot right here a scalar. Nothing's going on with it, doesn't mean anything outside of other stuff. There's no direction to it. However, once you get up to the next degrees, for example, let's take this array right here, this would be considered a rank 1 vector, essentially. So a vector is data with direction for those in linear algebra. So for example, popping back to our lovely x and y graph right here, one thing you could do is determine a vector to kind of be like this. It uses the x and y to be plotted across here in some direction. And that's what makes a vector, essentially. So for example, if we were to pop over here, and as we discussed in the previous video, due to using the Google Code Laboratory here, you are actually able to choose versions of all your code. And as you can see, we are using this version right here, which is awesome. Now we don't have to worry about any of that stuff, and it's all being run inside the Google system. So if we define our scalar and then we print it right here, this is it right here. This is the variable. The shape has nothing in it and the shape refers to essentially arrays or how they're built or what have you. And for here, there are none because it is a scalar. The type is int32. This means it's an integer of 32 bits. So yay, very standard. And 0 being the rank 0 for a scalar. So the thing is, with these vectors, they can also go up to higher and higher degrees. For example, this one would be a rank 1 right here, which is essentially just along the x-axis, along the y-axis. There's 1 degree of dimension to it. And then this one right here, you can see it's an array inside of an array, so that would be 2 degrees of dimension, which is essentially represented by this, 2. However, the thing is, with these tensors, you can get way, way higher as far as the dimensions. So for example, let's say we took this, right, and we had a 3D graph instead. And please excuse my MS Paint skills. I am not a skilled artist. So we got our x, our y, our z, right? Let's say we have x down here, we have y over here, and z right here. We could have a point somewhere on this plane up here, but maybe we have a tensor going this way, right? And on this tensor, it includes, it has the values for the x and the y and the z. It could be something like 3x plus, I don't know, 4y equals z. And yes, terrible, terrible writing. But the point is that essentially this tensor takes in is a function that uses all 3 values. Usually it's defined as the last one. So for example, z equals 3x plus 4y or something, right? But the idea with these vectors is that when you're given 2 of these 3 variables, you can determine the third one. You can calculate it, right? For example, let's say we had z and y. You could calculate x. You had z and x. You could calculate y, and so on and so on. So for example, the famous slope formula y equals mx plus b is actually a really good example of a 2D vector, for example, because it essentially graphs the relationship between x and y on that 2D plane. And with this one, it graphs the relationship between z, y, and x along that plane. So the thing is, essentially based on those three values, going back to earlier, since you're able to determine the last one, you can extrapolate that into further and further dimensions. Unfortunately, since we're trapped in three-dimensional space, we can't exactly move on to the fourth, fifth, sixth dimensions or whatever, but we can calculate it because math is incredible. So let's say you had a fifth dimensional array or vector or what have you. The idea is if you were given 4 out of the 5 variables, you could figure out the fifth. And that's kind of what TensorFlow does. That's how a lot of these machine learning programs work, at least in a linear regression context, which we'll be getting to in the next video. So let's say you had x, you had y, you don't know z, right? But you can guess. And odds are, first time, you will guess wrong. Terribly wrong. But if you're given x and y, a different x and y again, but you know it's the same formula, you can guess the second time. And maybe you'll be a little bit closer this time, and so on and so on and so on. And you can kind of start to try and predict what that z variable is going to be, which gives you insight into what kind of slope, what kind of formula, or what kind of relationship they actually have. And that's what TensorFlow does. It guesses, it checks, it guesses and checks based on its inputs and then testing against an unknown output. And if the output is correct, if it's wrong, it'll move its variables around, it'll assign different weights, and it will continue to test until it eventually gets it. So I know it can be a bit of an abstract process, so there's a really good example that I like to use sometimes. Now let's say you walked up to a person on the street and you asked them how much a single banana could cost, and they said, what, $10? Which, a little high, but it's just a guess, right? We could then graph that, right? So we take our x and y, and we say we got x down here, and we got y down here. And they say one banana is worth $10. And right now, this is just a single point. But then we go to a second person, and let's say we ask them what 3 bananas is, right? And they say it's $27 up here, okay? 27. And we ask somebody what 10 bananas is, and so on, right? Let's say we ask 10 bananas, okay? And they say 110, way up there. And this is not an indicative graph, so please excuse me. But the idea is, using these points, we will plot that line, which kind of gives us insight into the overall function, what we're looking for, essentially. And you might be asking yourself, like, what is the point of this, honestly? Because what's the point of TensorFlow if we can just do it by ourselves? Because that's a pretty good estimation, and I am freehanding it on MS Paint of all things. If you use the calculator, if you use a graphing calculator specifically, you can even use the line of best fit, which is what it finds. But the question comes, when you move on to higher dimensions, right? Let's say you have 4, 5 dimensions, you can't really graph that and find a line of best fit as easily, especially when you start using abstract values, right? Like, let's say there's a really good example that I like to use, which I originally picked up from the YouTube channel Free Code Camp, which actually has a 7-hour in-depth lecture about TensorFlow and how to use it. If you want to check it out, I definitely recommend it. It is an awesome resource. But one example they used was the Titanic falling, and we have a lot of data about the people that unfortunately perished on the Titanic. And we know stuff like their sex, man, woman, what have you. We know what cabin they were staying in, how much it cost, what kind of conditions they came from before, how long they were on the boat, where were they on the boat when they died or didn't die, and we know if they lived or not. And so we can use that kind of data, and that's not exactly something you can plot on a 2D graph like this, for example. However, it is something you could do with TensorFlow. So getting back to this real quick, let's just go over the other vectors, for example. Like we print out the rank 1 vector right here, right? And you can see here the shape is 2, blank. So the blank refers to the data in here, but the shape right here is, how do I put this? It is the number of items. So for example, if we look at this right here, right? We have two items in a single array. So this 2 refers to the last thing, which is 2 items. And then if we look at this one, for example, it's 2 arrays of 2 items each. So if we change this over to the rank 2 vector, we end up with a shape of 2, 2, where it's 2 items, 2 arrays. And this applies over and over again. Let's say hypothetically we just added an extra array on each of these, right? And then print it again. We get 1, 2, 2. So you start with your container, right? And we have one array that contains 2 arrays, and then each of these 2 arrays then contains 2 items. Now, the really important thing to remember about TensorFlow is that it requires all your data to be in the same kind of format. So, for example, if we do this, right, where it's an array of 2 items and then an array of 1 item, it breaks. You can't convert non-rectangular Python. So it has to match up with the amount of data in each subrow or section or whatever. It always has to be the same. Otherwise, it breaks because it can't extrapolate the data properly, and that's a big part of how TensorFlow works. So for that example that I was using right here, that's essentially called linear regression. It's one of the possible algorithms that you can use for TensorFlow. And essentially, that's what we're going to be doing in the next video. We're going to be taking a linear regression plot. We're going to be taking the data from the Titanic. We are going to be writing a very basic machine learning algorithm that will go through and determine how likely it is for a given person. Let's say we have a random stranger, they're a guy, they were in the second most expensive cabin, and they were at the dock or the main deck when the Titanic sank. How likely is it that they managed to make it or not? TensorFlow will be able to determine that for us and tell us exactly how likely, how confident it is. And that's what we'll be covering in the next video.